Hey again, thanks for tuning in to follow my process on how to build a record lathe inside a suitcase. Together with a few others, we rented out this old workshop and turned it into our own workspace. In this episode I will show you all about the frame, the structure hidden inside the suitcase that will make it possible all parts stay in place, even when the box is carried around. For more background on the project, check out my other episodes, or just click on the link in the upper corner here. If you like my videos, you can support my channel via PayPal me. Let's take a look at the frame, the structure that holds everything in place. First, I printed some templates to drill holes into the suitcase. I used different templates for the front and the back to get the hole positions right. The 20mm aluminum profiles will go somewhere here. To mount them to the inner walls of the suitcase, I'm using T-slot nuts with a ball spring. The spring keeps the nuts from sliding around inside the profile. Because the suitcase walls are slightly angled, I had to 3D print some parts to correct that. Four of these printed parts sit on the top of the T-slot nuts. This way the aluminum profiles sit at a perfect 90-degree angle. Now it's time to drill the holes into the suitcase. The aluminum profiles can now be mounted to the inside of the box. I choose a modular design for the frame. That's why I already included adapters into the aluminum rails. They will help me easily attach 3D printed parts later on. Next, the crossbar needs to be cut to the correct length. I'm using a standard chop saw with an aluminum blade. Now I can install the crossbars. I'm using standard mounting brackets for that. That's it, the frame is done. It forms the base where nearly all other components will be mounted. So now we can move on to the main assemblies. Let's take a look at the feed unit. Here's my first concept for the feed unit and the feed carriage. I used guide rods with linear bearings. These are very affordable, but they need extremely precise 3D printed parts. Otherwise the carriage can get stuck and move unevenly. Another issue, the large 3D printed parts. They just took too long to print and slowed down my iterations. Here you see the two guide rods. Between them I plan to place the stepper motor and drive belt. These small parts are the bearings. In setups like mine you usually use one loose and one tight bearing, but in the end it still felt too unstable. So I had to change my design completely. So I ordered a few different linear guide samples to test. In the end, I already made my decision, but if you have other ideas for the guide system, just let me know in the comments. Thanks to the modular frame, I can easily attach small 3D printed adapters. This helped me iterate much faster and improve the design step by step. For now I've decided to use a T-profile linear carriage. This is what it might look like. So let me explain the setup again for clarity. The base frame is mounted to the inner walls of the suitcase, which acts as the machine's shell. The feed unit moves the embossing head, which is attached to a lever arm. The carriage travels along the T-profile linear guide. A stepper motor drives a belt that moves the carriage. Everything is mounted to the aluminum frame using 3D printed adapters. So that is what I'm planning to build in the next episode. So hope to see you next time. In the next episode I will dive deeper into the construction of the feed unit and the lever arm.